Hello everyone, in this video we are going to see binary trees mirror tree. Here we have a sample binary tree. Here we have the known definition. It contains data, right and left pointer. In this program, your task is you are given two binary trees and you have to check whether the one binary tree is mirror of the another one. Here in this example, you can see this two trees. If you keep mirror, you can see this mirror reflection in this tree, because when 20 is here, it is here, so you can see this exact opposite, and 30 also, and 10. So this is a kind of a mirror effect if you keep one mirror in this line. So what we have to do is, our task is whether these two trees are mirror or not. We have to print true or false, or 1 or 0. Okay, how do we approach this problem is, we are given one function, this mirror tree, and you're passing this first node and second node from these two, and in function body we're going to check whether these two are null. What the incoming node is null. This is a useful condition at end of this. Leaf nodes are there. This is a useful condition there. Okay, here if it is A or B, any one of is null and one is not, means that is not a case of a mirror tree. So that time I have to return it's false. And the data is mismatching. So here you can see 20 is there, in case here 30 is there and here 20, then it is not a mirror. So you have to return false by that time. And what I do is, I have to recursively call this function taking left pointer of the first tree, and I have to take the right pointer from the second tree. So that time I have to pass the alternative, so left and right, and when in the opposite side I have to pass right and left. So that time we can achieve a mirror tree easily. So that's what we are going to do in this problem. In this one you can see this is not a mirror tree. Here you can see this is a different one, and here it is a right arm is here. But in this tree you can see the exact opposite of it. When it is in green color, it should be in here in maroon color. When it is here maroon, and here it should be exactly opposite. And here this nodes are like flipped. Okay, and this tree is a mirror tree, and this is not, and this is a mirror tree. Okay, now we just write this same snippet in Visual Studio Code, and we'll execute if the code is working for this mirror tree checking or not. Here you can see my basic setup. I have imported the necessary statements, and here I have class node, and in public I have written the node definition as data, and right and left pointers, and here I have the constructor. And int main, I have these two trees. First tree called n and second tree called m. These two are mirror trees, and I have one more tree called y, and this is nowhere relevant to these trees. So you can see some absence of some data. So when I compare this the n and n tree and m tree, it should print they are mirror tree. And if I compare this n and y, it should print it is not. So the answer for first one, it should be 1, and the answer for the second one, it should be 0. Okay, we write the function. I'm using int. You can use boolean also. So int, you can type mirror. It expects two parameters, so node A and node B. if not A and not B, return true. If not A or not B, return false. Because if any one is there and one more is absent, in that time it should return false. And if it is a data mismatch, that time you have to return it as false. And you have to return the recursion of mirror is left comma B is right, because oppositely I have to travel, and we have to undo these two, mirror B is right and A is left. And here it is same, so here A is right and B is left. Okay, and format the document. Yeah, here in how this works is, here when you have no notes are attached, here it is, and here where is 70 here. Okay, here the left pointer and right pointer here that we are passing, and it is this one is null and this one is null. What this first statement does is it should return true. So this is the exact mirror. It should if it is appearing this corner end, the exact mirror will be supposed to appear here, the most utmost part of this one here, this most corner. Okay, now combining these two should return true, then only it is correct. Either of one is null, then it is false, and if it is contains data mismatch, so that time also it is a false. Okay, and all these conditions are undone and the final result should be 1, so then it is a mirror tree. Here that's what we have done here. Mirror, we have to pass A is left and B is right, and when A is right goes, and it should be B is left. Okay, first condition is these two. Let me just erase this. The first condition what does is traveling like this, and the second condition is this one. This is second and this is first. Okay, now we run our program and we'll check. Here I have to write cout n mirror. I have to pass A and A as n and B as m. The same thing, I have to pass n and y. Okay, we run the program now. So run 1 and 0. Those two are mirror tree, and these two are non-mirror tree. So we got our answer as 1 and 0. So hope you understood this problem and the solution. Thank you for watching this video. We'll meet in the next video.